Hello. I'm Vanessa. I work at Model, and there will be a quick bit about that in a second, but I really wanted to talk to you about the experiences that we've been having in developing tools for game development that are based on AI and how they are used and like received in that space. Because everyone has their existing workflows, right? And then the question is like, do you even trust what comes out of it if you don't understand it? So we've had some experiences with that, both like while I was still in academia and now. So I'm just gonna share some of these things, and then hopefully, if I can be quick enough, there can be some interesting discussion about it, or otherwise afterwards too. Yeah, as I said, I have an academic background. I actually did a postdoc here at Queen Mary, but now I work at Model AI, and we're developing several types of tools that are supposed to help game developers. So this includes automatic testing, but also generating different levels, figuring out how to find bugs, how to figure out what the win rate is. So like several little things that could hopefully help. Yeah, we've had some initial experiences with that. Research-wise, I just love benchmarking, so that's my main thing, and general optimization, evolutionary optimization specifically. I am not going to go into detail. If you want to know more about Model AI, please come have a chat with me later. I think that's not the main point. We are growing. Things are happening. Anyway, so when I first started at Model, which was like 2019 or something, there was this big hype around using GANs because they work really well on Mario and on Faces and on several different spaces where you have. So the idea there is that you generate levels or artifacts in the style of ones that you've seen before. And we tried it on Mario and it worked decently well. So we were like, Candy Crush Saga has way more levels now, by the way, way more than 7,000. And we worked with King at the time to see whether we can just apply the same strategy to Candy Crush Saga games, because I mean they're both tile-based. It seems to make sense. There's a lot of data, and well, the first results were a little troubling. You see on the left the original types of level. I tried to give you a selection of different things. You can see all of them have some sort of structure. They usually are symmetric, although this one is not. But as a human, if you want to look at this, you kind of understand the groups. You kind of would understand where to start clearing things. So there's an intent behind it, right? Which makes sense because they were designed by humans. If you then look at our first attempts with the GAN that I just mentioned, and an MRF, which is a Markov random fields, different type of modeling the distributions, they are viable levels, and they might even play well for a bot, but you can clearly tell something is lacking, right? Just looking at it. So we'll go through what happened, but I'll spoil in advance. You'd be lucky to know that it actually did work out. At some point, we did manage to launch with another game company, and they were using our level generation and win rate estimation, and we're very happy with it. So that's why I'm hoping you can listen to me further, and our experiences are actually useful. So going into the trust bit, because when we first started out working with all of these companies, they usually have a lot of questions on so many different levels. For example, how accurate is the win rate prediction? And they wouldn't even necessarily phrase it like that, more like, can I trust this? Or like, how helpful is it? And also questions like, if I'm changing something, would I still be able to use it? How often do I need to update it? Can I then trust it afterwards? And at some point, you can't answer all of these questions, especially if you're trying to go to like productizing and not consulting, right? Where you want to just give a tool to a designer and they hopefully are able to find a way around it. So what my point of this, or like my learning from this, is that to make this easier, ideally, the people that are using it have some level of understanding of what is going on, right? They might be able to reason, okay, if I'm introducing a new mechanic, but the bot doesn't use the mechanics, it doesn't have a like representation of it, it might still work, right? So, and if you have an understanding and at the depth that is useful for you, then you might be able to answer your questions yourself, and then that can make you feel like you have like a good way of interacting with it. You kind of know what you're doing, you know what you're expecting, and that can generate trust in the system. The problem is that it's not just about knowing how it works, which is a problem, right? Like a lot of our stuff, like the deep learning and whatever, is black box. So we might not even necessarily know what's going on fully. But the other layer is communicating that to people that might not have the background. So these are like the two things I kind of want to talk about of what we tried to do here. First, about figuring out the knowledge bit. This is a quick introduction to the generator that I was mentioning earlier. It's called Generative Adversarial Networks, or GAN. And it is basically two adversarial networks where one is trying to forge an artifact, for example, a level, and then the discriminator over there is trying to decide whether that's a fake, like a generated level, or real. And because they are training adversarially, right? So ideally, if they go in the right direction, they will make each other better at their respective jobs. And then at the end of the day, you take the generator and use it to generate levels. And that's the gist of that. So what we did is we took this whole thing, plopped it together with a simulator, and used that to evaluate all of the artifacts that come out. And we used a lot of different functions to evaluate, and these are all from like academic literature. I'm taking no guarantees on whether they actually evaluate something useful. That's a whole other topic which I have a task force on. But the idea is to kind of figure out, well, this sounds reasonable, right? And we can see it's doing sensible things, and we can explore the space. But if we don't understand it in detail, how can we then have other people trust in it if we don't understand the intricacies of what's happening? Right. I wasn't trusting it. That was my problem. So this is actually recently released. This has been very long in the works. This is an attempt of understanding this space of generated Mario levels in this case, but it's the same method. And we were trying different systematic analysis tools to figure out what is actually happening. How is the landscape actually looking, and why is random search so good? Because it happens to be very good, and that is a little concerning. So I don't want to go in too much detail here. My point being more that I think it's very valuable to start analyzing the stuff that we're doing, and this includes all the explainability stuff, but also in terms of how you can then use algorithms on top of it. From like an optimization perspective, for example, this space is very difficult. Yeah. The other part is that a lot of these different functions rely on evaluation via bots. So same problem again. What do the bots do? Do we understand it? And in this case, for our collaboration with the puzzle game designers, we ended up going for a very simple approach that is actually explainable in itself to kind of nip this problem in the bud a little. So this is based on dynamic scripting developed by Peter Spronk back in the day. And the idea is just that you have a set of rules, and through an iterative process where you get feedback on whether this rule worked well or not, you get an evaluation of the rules. So then you are able to figure out which rules work better and which ones work worse. And then you can just select the really good rules, the green ones, for this bug. The interesting bit here is that the rules are kind of in a language that you can understand, right? You define the rules yourself. You need a lot of domain knowledge to do it. But then you can actually read what rules were successful in the end. For example, non-surprisingly, preferring score increase if the score does lead you well around the game, that is actually a very good rule. Sometimes you don't need much more in some games, but at least we can understand what's going on, and we can also design specific strategies. Talking to game designers, and they're like, well, you need to make a lot of power pieces to clear this level. I could write that up in that format. This is not usually the way you do it, but you can. And so going for something that is easy enough you can actually understand it. The last bit that we really ran into is changes in the problem formulation. So we were happily coding away, was working, we were doing win rate prediction, and suddenly the game developer was like, but now I want multi-objective levels. And none of our rules were looking at multiple objectives. They couldn't evaluate that at all. So we had to change that. And suddenly also the objective was not performance, in terms of win rate, but predicting human performance instead. So that was a communication problem, I assume, because I assume they were very relatively clear that's where they wanted to go. Although it was very iterative in the process of, oh, this is what I actually can do, can I then do this? Right? So trying to demonstrate what is possible takes a while if you don't have an existing example of how to interact with these tools, which is why demos are really useful, we found, so even small ones. But, well, things were changing, and I was despairing. But I think the things that we took from this was you kind of have to work with it. It's always going to happen. So if you're really close to industry and developing AI for that, you're going to have to embrace it, make something that can, if the game dev iterates, you just can react to it quickly. So something new gets introduced, you just have an easy way to retrain things. Or there's a major overhaul, so you can just plug in a new system. Stuff like that was very helpful. But on the contrary, there was one interesting bit where they started a new game mode, and we were actually able to help them imagine and design levels before they even implemented them, because we had the abstract representation. So we were actually helping them out in their game dev cycle and sped it up, which was pretty cool. Because basically they couldn't render the sprites, and we just rendered them in different sprites, and then they could design with a new game mode. Right. How much time?
Approximately 5.
Nice.
Okay, I have lost track of time to go.
Okay, I think this is my last slide. Yeah. So my point being that if you want to understand it, you need to actually, well, to generate trust, you need to first understand it. So there's a lot of things that there's a lot of potential to analyze. There's a lot of cool milestone AI out there that we don't properly understand. We don't understand what happens if the patch changes or whatever. And then I think there's a lot of work to be done around communicating with people, understanding their workflows, understanding how things can fit in there, understanding what terminology they use. And for that reason, it really cannot be done alone, because you need like an interdisciplinary team to do it.
She's looking at me, so I'm going to stand up.
Yes.
Questions? If we can take one or two now, but there's always more time to chat for afterwards. Yes.
So did you implement difficulty levels for the rules area?
Yes, so what we did is we first tried it without any additional data, just on a lot of features, like 120 that we could think of on the levels themselves, and had a very simple linear model because we didn't have that much data on humans. That didn't work out. What helped a lot was having the bot run. So I think like to get basically a rank correlation going. So the bot doesn't necessarily need to play at the same level as a human, but if it can rank the levels properly, then that is a really good input, which is very helpful. And there are other studies that do this too. So you have to have a decent level, but the main point is the ranking. And another big challenge that we had was what to actually predict. This is like the mean or the median, and there's a lot of communication problems there as well, because they seem to be interested in the mean, but there was so much noise on like basically a very long tail, and people with ridiculous amount of like 5,000 times trying the level, which who knows how that came to pass. But like communicating around how to like make the data meaningful, or like what to predict, what the different challenges, and cleaning that up.
Thank you. Great presentation.
Thank you.
We have Simon in the back.
Hi, Vanessa. Great talk. Thank you. When people train GANs, they normally throw away the discriminator. And I just wondered, I mean, that's the thing, you should trust that. And I was wondering whether you thought about using that in a clever way to give you some trust in the generator, because it should give you some. And these days they're not critics; they're they are critics.
Yeah.
Rather than discriminators, so they can give you a score for the level. And I was wondering whether anybody tried that using the discriminator there.
That's a good question. Not that I am aware of. I guess the thing is that it'll be like biased, right? Because it's trained together with a generator. What would be really cool is train a different set of GANs, and then get a bunch of discriminators together and be like, hey, what do you think? Yeah. I mean, I'm sure someone must have done that. I'm not aware of any work. We definitely haven't looked at that.
Yeah, it can't be an idea.
Yeah.
But that wouldn't give you much. That would give you like a score. But you really need more qualitative information about what.
I think the thing is, if you still can't get into depth for the discriminator either, right? And the problem usually is you have a very limited set of examples, so you can only really trust the discriminator on this, unless you really understand the space that it's reliable on. So I guess you could do some additional studies, like adding additional levels and seeing whether it would be real, right?
Yeah.
So I think there would be additional things to do to understand and trust the discriminator, just because it's deep again, right?
Sure.
But it would definitely increase it, I think. I've actually talked to some person on variation ultimate coders as well, and also on comparing those different spaces.
You've got the layers in the VAE or the discriminator, so you could perhaps do what they do with machine vision, which is look at what the layers.
Yeah.
Yeah, that might be some quality.
Like the attention and where it looks at and stuff.
Yeah.
Yeah.
One quick Final
Hi.
question.
Thank you for a good presentation. My name is Josh. I'm from Candy Crush Saga. Candy Crush
Oh.
Saga.
Sorry.
I'm curious, what was the results of using AI in generating levels? And are there any levels generated by AI implemented in the game itself now?
In Candy Crush, no. So the thing with King was more researchy, and we basically stopped at some point where like funds were running out. The game that we managed to do was by Good Games, which is like a German development studio. Yeah, we're still in talks with Candy Crush, but as far as I know, they don't have any of we have an API, but that's it.
Well, I think this is only a matter of time. So because there is an interest for generating levels. So I think probably it will work again. I'm not sure.
I mean, there's always like, there's people involved, right? And they might not be necessarily really into it, and some are really into it, so it's a balance. But great to know.